So the first section was just an introduction. So we'll be moving into the section 2. Yeah, coming. So in section 2, we'll be diving into what is AI, ML, and deep learning, because these are terms that are used interchangeably. Are they the same or are they different? What are the differences, similarities in them? So it is in this section we'll be diving into that. And what are the types of machine learning that we have? Because this series is majorly focusing on AI and machine learning. So we need to understand what the AI hierarchy is. So I don't know if you can hear me. Can I get a thumbs up if I start? All right, thank you. So these three terms, AI and ML with deep learning, they are used interchangeably, but they actually mean different things. Yeah. So when we go forward, you see the reason why they are being used interchangeably, but in the real sense, they mean different things. So understanding their relationship is one of the most important foundation that you will need in this field. So the artificial intelligence, what does it mean? AI for short. You keep hearing AI, AI. AI stands for artificial intelligence. So that means intelligence that is not natural, that is artificial. So it means making machines simulate human intelligence. So we can describe human intelligence as well as natural intelligence. So when we're not trying to make machines simulate the way humans think, reason, that is what artificial intelligence. So machines will simulate human intelligence, the way we reason, the way we learn, the way we solve problem. So that is what artificial intelligence is. And this is a broad category. That is the broadest category. It contains a lot of things. So AI is like the the broadest category, yeah. Then example is most of the assistants we have on our phone, Siri, Google Maps, Google Assistant, all that they are what? The artificial intelligence being used, AI models. So then what is machine learning? Machine learning, ML for short. Machine learning is a subset of AI. I will say something is a subset, is inside AI. I'm coming, let me see if I can use a pen or something to draw. Okay, I need a pencil or something to draw. So when we talk about machine learning, is a subset of AI, and it has algorithm that learns patterns. So we can say machine learning is just what algorithms. The algorithms are what that learn patterns. Algorithms. So it learns data without being what explicitly being programmed for every rule. So I believe you understand what our traditional programming is. In traditional programming, we will write rules, ML, we write rules. While in machine learning, the machine will be the one to find the rule. I'm coming, let me try and get a point. I just want to be able to write and do some things. All right. So I believe you can see my screen. So machine learning is a subset of AI. It is the algorithms that learn what patterns from data without being explicitly programmed for every rule. So that is what machine learning is. So where's my paint? So now in traditional, in our traditional ML, in traditional programming rather, we have we will program the rules. Yeah, we will write the rules. with data, then we will get the results. We have rules. I'm coming. Yeah, this is it here. In traditional programming, the developer write the rules. Yes, as I said earlier. Then you apply that rule to your data to get an output. That is that is what we mean by explicitly programming the what? The We have rules plus our data, then it will give you what? The output. So this is for traditional programming. So why in machine learning, we have what? Data. We have data, then we give it the output. Data and also give the output. In machine learning, developer will feed the data and output examples. Then the computer will learn the rules. Then that rules that the computer has now learned will now apply it to new set of data. That is the way machine learning works. So we need to understand this part, the way machine learning works. That is how machine learning is different from traditional programming. In traditional programming, we write all the rules. I can write, okay, when I have this data, to get the result, perform this. If this is this, compare this, do this. I'm doing what? I'm explicitly programming my system or what I want. So, but in machine learning, you just get the data plus output example. Your output example, then the computer will do what? From it, the computer will learn the rules. Computer learns the rules. So that is in machine learning. So the rule is then applied to new data. So this is the reason why we need data. You say, this is why you need data. When we have data, from your data, you will have some examples of the results that's gotten in the past. So then is that result you feed into your data. The programming we will now do in machine learning is what? You know, in their definition, we said it's algorithm. So the programming we are just doing is we are writing the algorithms. We write the code to process the data, because you need to do data processing. I mentioned that in the first section of this series, where we will need to process your data. You need to clean your data. You need to visualize. So that is the code you are writing. Your code is just to process the data, to visualize, then to write the algorithms, because we have different types of algorithms that you can use to work on your data. So, and there are different reasons why you can go for a particular algorithm than another one. So that is the program we write. We are not writing the rules. We are just writing an algorithm that will learn that rule. So that is what is being done in machine learning. So example is Netflix recommendation. When you are watching movie, it will recommend some movies for you, or even based on your watch history. It will recommend movies for you. Spam filters, we have this one in our mailbox, where you have some messages automatically going to your spam, yeah. And we have maybe like fraud detection, yeah, and maybe Flutter or some financial fintech apps. So now when we talk about deep learning, DL for short, deep learning is a subset of machine learning. So in deep learning, we talk about neural networks. So we talk about neural networks with many layers. With many layers. So in deep learning, it learns complex patterns. Patterns are being learned in machine learning. But when you want to learn complex pattern, you use deep learning. So this is usually used for audio files, images, and sometimes we use this for text, but it learns complex patterns. And it is the one being used. Deep learning is what is being used to power most of our advanced AI applications today. Where we talk of CNN, convolutional neural networks, that is under deep learning. Deep learning what? Learns complex pattern. So deep learning is still under machine learning, but what it does is it's machine learning is just simple algorithms, while deep learning takes it further and it works with what? Neural networks. The neural networks imitates the way our human neurons are being connected, the way our neurons are being wired. So it tries to imitate it, and it has many layers. So it now boils down to you to define how many layers your your model will have. So example, ChatGPT face unlock. Face unlock requires your device to be able to recognize your face. So deep learning comes in place. Machine learning won't be able to do that. If you are doing that, maybe you are just giving it some picture, it will just do some basic classifications. Yeah, but it won't be able to recognize this face is for this person particularly. Deep learning is excellent at that. Speech to text, because it requires audio and some powerful translation, maybe from your speech to text. Self-driving cars. So these are real world examples that are being powered by what? Deep learning. Deep learning. Yeah. So I wanted to draw a diagram the other time. We have, I'm coming. Me. Let me have this. We have this. We have this. And we have this. So this is AI. This is AI. So you can see the bigger circle is what? AI. That's why we said it's the broadest category. So it is under AI that we now have what? Machine learning, ML. It's under AI that we have that. Let me try and move it. I'm coming.
This thing is making sense now.
So we have now. So under machine learning now, we now have DL. So ML is a subset of AI, while deep learning is a subset of what? Of machine learning. Let me know if you get that. Hope you got that. What I was trying to explain here. Thank you. So ML is a subset of AI, deep learning is a subset of machine learning. So they are all related. So, and we said DL now powers most of the AI applications we have today. So you can now see when you have a AI model and it has the machine learning inside, it's either uses machine learning or deep learning. So you can now see the reason why they are being used interchangeably, because you have your AI models. So it contains a lot of things. But for the AI now in your model will need to learn some rules and some, because artificial intelligence, you are trying to simulate human reasoning. And before you can simulate human reasoning, you need to learn some things. So where that learning comes from is from machine learning. It can either be pure machine learning, the classical machine learning, or the deep learning. So that is why most times we use them interchangeably, because if you want to develop this, you still need this or this. So I feel that is the reason why it's being used interchangeably. But in actual sense, they mean different things. So that is just the relationship. So the key insight here now is, in traditional programming, just as we explained, you write the rules to get this A plus B will give you C. So anytime I give it and I give A can be anything, B can be anything, it will automatically add and get a result. I'm just using that example, rules. But in machine learning, I can just give it the answer I have is 4. 4. And I give it maybe 1 plus 1 is 2. 2 plus 1 is 3. Those are example. I give it to the model and I give it my data 4. So the computer will, okay, I give it the computer will try and learn. Oh, how does 2 plus, how is, maybe to learn from the example, 2 plus 1 is what? You have 2, you have 1, and you have 3. What is the relationship between 2, 1, and 3? Oh, it cannot reason. It's like they are trying to do addition. It has 1 and 1 is 2. How is 1, 1, and 2 related? Oh, it's like 1 plus 1 will give you 2. The computer will be the one to learn the rules itself. That is why you see, we say sometimes the AI models, they are not perfect because they are trying to learn the rules. We call AI a probability. AI is probabilistic. It's not deterministic. Why? Because I think we mentioned that in one of our section. No, okay, I think it was a class, embedded system class, where we mentioned that embedded systems are deterministic. So let me write it out. I will say we have deterministic versus probabilistic. So now, let's say you are doing traditional programming. You are writing the rules. Your results will be deterministic. Why? Because once you give it an input, it will apply that rules, and so far the rules is the same. Your answer can never be different. It will always be constant throughout once the rules is being applied. But if you are talking about probabilistic, once you give it your input, you can run a AI model and you get a result. When you run it, even on your own model, another time you can get a different result. Another person will run it, it will get a different result. Sometimes it might be similar, but you are getting different results. That means is to tell you that is what is probabilistic. It's not really sure of his answer, because if it's really sure of his answer, it will give you a specific answer, and no matter what. And even sometimes after a model has given you your answer, you can try, are you sure this thing is correct? What if by you promptly doing that kind of thing, you are trying to play, did I say emotion? AI does not have emotion. So it will not try and, because it's not really sure, it's trying to learn. If you tell your model that this is the correct answer, it will learn it and it will start giving you answers based on what you told it, because it believes that is the truth. It's trying to learn. So that's why we said it's probabilistic. It just gives probability. Okay, we can tell you I'm 90% sure. You can ask how sure are you? It's when you're asking how sure are you, I'm 100% sure, 70% sure. That is where probabilistics comes in place. And when we go into maybe classification model, you actually understand why you said even AI model is probabilistic, because for it to classify, it takes, maybe you want to classify an email as spam or not spam. It will, maybe the probability of it being spam is 70%. The probability of it not being spam is 30%. So which one is higher? 70% is higher than 30. Then automatically it will believe that mail is not what? Is a spam mail. You can see the way it works. So it works using probability. That is why we said AI, machine learning, they are probabilistic. Are we getting that?
One thing about me, I will tell you.
So think of ML, machine learning, as teaching a child by example rather than writing a rule book. Just think of it, you have a rule book and you give it to a child. When you give it to a child, because the child will be, we have the way they are able to assimilate might be different. If the child decides to read the book, yeah, good, but it might not be able to get all the rules. It's just like explained by a rule book or so. But if you try and teach the child by just giving the child example, when you have this, automatically, even you not teaching the child the rule book, the child can also learn by example. So that is, just think of ML as you are giving example to a child. You are not giving the child the rule book. The child will not determine, this is the reason why this is this and that. So since we've understood the difference between AI, machine learning, and deep learning, we will now be taking this further into what? Machine learning. Machine learning, AI, they are related. Most times we use them interchangeably. But if you are saying you are into AI, you still need a good understanding of machine learning. It will help you in AI. The reason why we said AI is broad is it involves some other category that is more than machine learning. So, but for now, we'll focus on machine learning, building models, and by the time we now start developing models and adding, considering some things, that is where AI will come into play. So, the types of machine learning we have three main learning paradigm in machine learning. You have three types basically. So, choosing the right one depends on your data, depends on the problem you are solving. You need to know your problem. What are you trying to solve? Your problem will determine the type of machine learning you will use. Then each of the type has different algorithms. So now with the three types we have is the supervised, unsupervised, and reinforcement learning. So I'll be explaining them. In supervised, sorry, I'm just trying to confirm. So in supervised, you have your data. Your data, you label it for the model. Oh, this is the data I have. This is the input. This is the output. You label your data, input, correct output. That is, you are trying to teach and guide the model to be able to learn the rule fast, to make correct decision. This is the input. This is what? This is the output. So it helps the model to learn. That is for supervised. While for unsupervised, you give it unlabeled data. You just give it data, maybe 1, 1, 2, or you just give it some data, you won't label the data. So the model will not be the one to learn. Oh, what this evaluation is the output, what is the relationship. We have case scenarios where we use them. I'll still talk about them. I just want to talk about the input data. For supervised, we label the data, just like as if you are giving the model expo. While for unsupervised, you are just giving data. The model will be the one to learn that on its own. While for reinforcement, you are not giving label data, just like unsupervised, but the agent learns via reward or penalty. The agents learn via reward or penalty. So this one is usually used for maybe robots, when you are developing robots models, or for even games. It's just as if you have a house, you have a building, an open space, you put a cup somewhere and you ask your model to go and get that cup. And there are different routes the model. Let's now use a robot, for example. Now the robot can pass to get to that cup. The robot can decide to go and pass the longest route until, because it's trying to just like try and error. It will try this one. Is it correct? No. It will try this one. Just trying and error. But by the time it gets to that cup, because it's taking a longer time, you will be, you took a longer time to get the cup. I'm penalizing you. I'll penalize you for that. Because you've penalized it, when you ask it to do the same thing, it will recognize that me going this route, I'll be penalized. And the aim of the reinforcement is to try to get the best results. So it try to take another route. It is that the model think is short. So by taking that route again, you can still be okay. I reward you. Now you are taking a shorter time. So the agents will learn through us. When we are talking about reinforcement, we now talk about agents. Yeah, because in reinforcement, agents is like, just like I made example, a robot. We have environment in reinforcement, because the environment is the space where you put your agents. And when you are talking about in reinforcement, you talk about reward or penalty. So how the model will learn is through reward or penalty. So it's try to get higher rewards. It's try to avoid penalty. So if you are penalizing the agents too much, it knows it's not learning very well. If you are giving the agents rewards, it knows, yes, I'm learning, I'm improving, I need more reward. So that is just that. Then and in unsupervised, the techniques we have majorly in the non-supervised, we have two major categories there, the classification and what and regression. So when we talk about classification, it's just as if you are classifying your like email example I gave, is it a spam or not spam? Whether okay, this picture is the image is a boy, the image is a girl, this cat or dog, those common examples. That is classification. Oh, this okay, you are classifying this person is a Nigerian, this person is not a Nigerian. That is classification. You can have is it binary class when you have those two classes, or you can have more than two classes in classification. That is also under classification. But when we now talk about regression, that is maybe you want to predict house price. You know, when you are predicting house price, you are talking about a figure. So regression is as if you are predicting a value, a figure. So you can't just say, oh, the price is around this price. No, you are predicting like an exact figure. Even though the figure might not be correct, that is, it might not be accurate, but at least it will give you an idea. Oh, based on the prices of the house in time according to history. So buying a house of this land, maybe the land is this, maybe two plot or so in this area, based on what the model has learned. Oh, I predict the house will be so a month by this year. That is how regression works. So those are just real-world use case. And a common example of regression is house price prediction, car price, stuff that has to do with values, yeah, or figures. So when you use supervised, when you know how to classify the data, you know how to classify data, but you want the program to do it. You yourself, you know how to classify data. Because okay, when I have this picture, I know this is a cat, I know this is a dog. Oh, when I have this, I know this is that. But because of another time, you can't be doing every data you'll be getting, you can't be doing them manually all the time. You want to like sort of automate it, or want the model to be doing it for you. So based on the ones you know or the past results, you give it to your model. When you give it to your model will learn it, and it will do what? It will start classifying it or maybe predicting for you. So when you know the answer, you know the results you need the model to get, use supervised learning. But when you come to unsupervised, we are talking about clustering, anomaly detection. When we say clustering now, maybe you want to categorize people according to location or so. You have their data according to age. By the time you feed in your data, the model can learn, oh, based on something, oh, these are the nearest neighbor, these people are close to themselves. Because they are close to themselves, the K nearest neighbor, or K means clustering. Yeah, I think K means clustering. It's like K nearest neighbor is under supervised. Those are algorithms. Under these techniques, we have different algorithms. Regression, we have linear regression. We have different algorithms under that. In the next section, we'll talk more on that. So in clustering now, it's just as if you are grouping. So you can just go online and just get the data, or maybe of some customers, and you don't know how you want to group those customers. Maybe they bought something from your store, and based on, you don't know whether to group them by the amount of goods they buy, or maybe from their location. So you can just decide, oh, group this customer, maybe you give it a cluster group. I want the cluster maybe to be like 2. So it will group those customers for you into 2 categories. The model will be the one to determine how it will group them. So unsupervised learning is used when you don't know how to classify the data and you want the machine to structure it. It's usually used for you like when you don't know how to classify your data, but you want the machine to do it. By the time the machine does it, it detects hidden patterns that you might not see. That's why we said machine learning can do that. There are some hidden patterns in data, just like the way data analysts do their thing. When they analyze the data, there are some hidden patterns in or maybe in the customer, maybe their behavior or so, that you might not notice. The model will get that and categorize them based on the number of groups you want. If you want 10 groups, can classify the customers into 10 groups. So, and it's also used in anomaly detection. That is where fraud detection comes in place. Okay, maybe based on the way a customer is purchasing things, it can detect anomaly means unusual behavior, something that is not the common way this thing has been behaving. So that when by the time it start detecting maybe a behavior that is unusual, it is used in detecting what fraud. That is how it's like maybe this person is just trying to log in multiple times. The model will be the one to say it's like something is wrong. There's an anomaly somewhere. So even though that's why but I believe the models have been improving over time, because sometimes it might be right, while sometimes it might be wrong. That is why sometimes you will see you are being put or maybe put out of your account for some reasons or all that. They are trying to avoid fraud because they are detecting unusual behavior, something different, anomaly. We call them anomalies, something that is not the usual. So that is on unsupervised learning. So, and in my reinforcement learning, I've given an example of that. Robotics, yeah. We even have them robotic warehouse arms. Warehouse is the environment you place a robotic arm inside. We also use it to train, like we now have AI models beating the world best in our chess, in AlphaGo, in some games. When you have the world best in, especially all these board games, the world best in those games, even for answering questions, trivia. I think I saw that. I think it's IBM. I've forgotten the stuff. IBM, one of the IBM models that answered question and won and beat the winner of that stuff before. That is to show you model have been improving. They've trained them over time through what? Reinforcement learning. We are trying to reinforce their learning. We are not giving them, telling them what to do, but they learn. By the time they keep learning, you penalize them. You are not doing very well. Even though they are doing very well, you can decide to penalize them. And if you penalize them, they'll still try and adjust and find a better way to do things until they are good. So we use this for sequential decision making. So when you want your program to optimize decisions in dynamic environment, because you can place that model in different environment and it will learn. So that is reinforcement what learning. So we'll take a deep dive into supervised learning. I've just give a short overview of them. So in supervised learning is the most commonly used type. That is what most of the time we use supervised learning. So our model is being trained on what? On label data. I mentioned that every input, it has a known correct output. That is, every input you are giving your model, you know the correct output. So what your model will now do, it will learn to map that input to the output. That is, what is the relationship between this input and output? What is the rule that is being played out there? Your model will be the one to find that. So by the time it finds that, it can use it to predict what? On new, unseen data. And I mentioned the two category we have under supervised learning. We have the regression and we have the classification. So in regression, you are predicting a number. I said it the other time, when you are predicting a figure, a value, that is regression. You predict a number. So example is house price prediction. For it might need the number of how many rooms does the house have, what is the area, that is the land area, is it plot, acre, location, where is the house located. Based on that, it can predict the house price. Maybe temperature forecast, what is going to be the temperature of this area at a particular time. You can use it to predict the student's grade. How will the student perform at the end of a semester or at the end of a session, based on the attendance, the hours the students are studied. So you can use it to predict what? The student's grade. Maybe the salary estimation, how much should someone be paid based on this experience, the role is working in. So that is regression. You are predicting a number. But when you are predicting a category, that is classification. You have what? Email spam filter, maybe based on the subject, body, or the person sending it. So disease diagnosis, maybe you have like even scan images. You can give scan images to AI model now, and it will predict if there's a kind of disease in the scan. So you can predict, oh, based on some symptoms or the test results, it will tell you maybe for that disease is positive or negative. So when we are doing this kind for disease diagnosis, because it's in medical area, there are some challenges there, because getting data to even train your model is a challenge. So that is why even for individuals, you can build this model, but for you to effectively prove your model, you still need data. And for you to get medical data, it's not easily accessible, because patient data needs to be protected. So there are ways those data are, there's the ethical aspect of it. Yeah, let me just put it, there's the ethical aspect of it. And another challenge is, you'll be able to predict positive or negative. If you develop your model, then you get maybe someone's test result or scan, and you give it to the model, and the person is having the disease, and is saying the person does not have the disease, negative. It might mislead the person, but that one is even still better. They can still now decide to, but it can mislead. But in cases where someone is not having the disease and it says the person is having the disease, when they say the person is having the disease, the doctor will now need to do more tests to know what is wrong. By the time they do more tests, they can detect if the person is not having the disease. That one is still safe. They are not having disease, but it's telling you are having, though it might try to raise your heart rate, BP like that. But in the long run, you detect you are not really having disease. It's the model that is not predicting correct. That one is still safe. But in cases where you have the disease and it's predicting that you do not have the disease, it can mislead you, because it will put your mind at rest, and you might decide not to go for further test or scan. Or normally you just believe, yes, I'm okay, I'm good. Meanwhile, you actually have the disease. So that is why in developing this model, it must be as accurate as possible. That is where you need to know about the difference between recall and precision, where we talk about the false negative, false positive, they all comes in place. So when we move into the further section, we'll talk about that. So maybe for loan approval, should you approve this person loan or reject it? Will this person default on his or her loan or not? They can use AI mode or supervised learning for that to classify loan approval. Image recognition, this one is common. Even though we said deep learning is best for image recognition, there are still some simple image recognition that you can do with machine learning. So in image recognition, maybe you want to predict these images for cat or dog or bird. You can do that. So let me know if you are still following. Let me get a thumbs up. All right, thank you. So for unsupervised learning, no labels are provided. As we stated the other time, you don't have any labels. So the algorithm will be the one to discover the hidden structure, and it will be the one to group the data entirely on its own. What we just need to give it, how many cluster do you want? Once you give it maybe 2, 3, 4, it will group your data into that number of clusters. So the most common technique that we have in unsupervised learning is clustering, though we have more than this. I think I'm trying to remember sometimes, I can't remember now, but we have more than clustering. Yeah, we have anomaly detection. We still have some other types in unsupervised learning, but clustering is a common one. So, and one of the algorithms we use for clustering is the K-means clustering. So we can use it for customer segmentation to discover maybe your customer. You can group them based on their budget, based on premium or seasonal buyers automatically. By the time you give your customer data to your model, it will determine maybe customer buying product once in a while. This is a seasonal buyer. Customer buying products above this price, these are premium buyers. Customer buying products maybe on discount, these are budget customers. You can see the ways you can categorize your customer. Unsupervised learning can do all that for you. You don't need to start thinking, how would I group my customers or segment them? Unsupervised learning is best for that. Maybe news grouping. It can cluster similar stories together. Oh, these stories are similar without you needing to be tagging it, doing manual work. Unsupervised learning is good for that. Genomics is good for that, for grouping genes with similar expressions patterns. Human have genes, you can be used for that. By the time you give the genes, oh, this they have similar expression, they have similar patterns, it can group them together. Anomaly detection, it can flag unusual bank transaction as outliers. I said anomaly detection is something unusual. And this now, even going by this example, I mentioned maybe trying to log in and you are trying to log in multiple times. It can flag it as what? As anomaly. So that is what maybe in fraud can be used for detecting fraud. Or maybe somebody making transaction. You have a certain amount of transaction you do make every time. But maybe just another time you are trying to make a transaction, maybe for example, you are trying to make a 10 million transaction and you've not made it before on your account for years. By the time you are making that kind of transaction, your maybe bank also will flag that transaction. They will try to dictate, are you sure? They will try and make some things based on what they put in place. So that is what anomaly detection, something unusual. Even though you might be the one doing it, but they will still first want to take what precautions to prevent what fraud. So then for reinforcement learning, an agent learn by what? By interacting with an environment. I mentioned it has like 4 things involved in reinforcement learning. We have the agent and the environment. These are what they are the most important. You have an agent, you place it in an environment, then it earns reward. So the reward can be positive or negative. When it's negative, it is penalties. So you give reward for good action, or penalties when the agent is taking wrong or bad actions. You penalize it. So it learns the best strategy over time through giving it reward or penalizing it. It's just like as a child, when you put a child somewhere and is behaving very well, you reward the child. So the child will know, this thing I'm doing it very well. You will try to do better next time. But when the child is not doing very well and you decide to flog the child, you are penalizing the child or you punish the child. Next time, oh, I should not do this thing again. Let me do another thing. So by the time he does another thing, if he's penalized, he will know he's not expected to do that. But if he's being rewarded, he will know he should keep doing that and he can even do that better. So doing that, the agent will learn what the best strategy over time. So it will take time. It depends. So it takes time. So for example, now let's say we now have the maximum reward. Maybe for the model, the maximum reward is like 20, for example. I'm just using that number as an example. So by the time you keep rewarding it, maybe the first time it does something good, you reward it with 1 or 2. And it knows the maximum reward is 20. The agent will know, oh, yes, I'm doing very well, but I have not gotten the maximum reward I can get. The model will learn and improve over time. By the time it gets 5, yes, I'm getting there, but that is not the maximum reward. So by the time it does it and get the maximum reward you can give it, which is like 20, based on what I just said now. So the model will feel, yes, I've arrived, I've achieved the maximum reward I can. So that is in the course of that is how it keeps learning the best strategy over time. So, and famous examples of it is AlphaGo, AI model and models beating the world Go champion. We also have it in OpenAI 5 beating the professional Dota 2 players. AI models are now beating humans in the game that they are good at. That is to tell you they've learned over time. They will have showed the video of even those players to the model. It will have learned the rules of the game. By the time it plays this, it will have learned very fast. Even when we play chess on your phone, you can play with computer. But you see sometimes you see maybe easy, hard, medium. How do you think is through all these models that they've learned. Oh, by the time I do this, I get the best score. And they can also adapt. By the time they play with individual, they adapt. By the time they see how you are playing, they see maybe they are penalized, all that, they adapt. So that is reinforcement learning is good for that. So now we'll just be doing some simple tasks. Now let's say some daily machine learning applications that we already use that you might not know, but I know most of us we know. Spam detection. That is unsupervised learning when we are talking about classification. This we can find in our email, whether you are using Gmail, you are using Outlook or Yahoo Mail. So this filters millions of emails daily using what? Supervised classification. The way this works, it will check the body of your mail or the header, the sender, if it's containing some unusual character. There are ways spam messages look like. Oh, you want this money, I will do this now, your account will be blocked. Something that shows a sense of urgency. It might be flagged as what? Spam. That's why even if you receive message from an unusual sender that has not been sending you mail before, and maybe the domain of the sender, especially people when you have a website or so, with the domain of the sender is not really that secured enough or so, it can be flagged as spam, even though it's not a spam message, mail. Sometimes when you receive mail over time, I discovered that myself too. So when you receive mail from someone, yes, the mail is legit, but maybe over 3 months, you've not opened any mail from that sender. The next time the sender is sending you a mail, it automatically goes to spam because it will think that mail is a spam because you've not opened any mail from the sender in the past maybe number of days or months. So, and the sender has been sending you mail, but you are not opening any of it. By the time after the specified number of days, it will automatically take that mail to your spam box. So another one is recommends content based on your viewing history. You can see this Netflix, Prime Video, even on our social media. By the time you watch YouTube, Instagram, Facebook, you watch one reels or another, you just see that over time, if you keep watching a reel or video from a particular maybe content creator or so, or a particular category, over time they will keep suggesting reels or videos in those categories to you. That is what recommending content based on your viewing history or based on similar users, maybe users in your category. These recommend content. I think that is should be supervised. For similar user, maybe unsupervised learning where you've been categorized on, maybe you've been categorized under some specific users. So maybe they believe the users in this category, these are the kind of things they love, these are the kind of things they watch. So another example is ranks and recommend the most useful search results. By the time you make Google search, you search for this, you will see that some results will come first, some will come second. That is to say, it's recommend, oh, this is the best result that fits what you are searching for. It will rank them. That is daily machine learning applications in use that we know or might not know. So another one is personalizes your feed and target ads based on your interaction. Social media again, you will just see that while scrolling, you will just get a particular ad. So it is based on what? On your interaction. And one of it is you might be using a website or an app. You just decide to go, I want to get this product. You decide to go to your e-commerce app, search about this product. You check another product. You will be shocked that maybe you just open your even YouTube or your Facebook or Instagram or so to check something. Then you start seeing ads relating to what you've searched, maybe on Google search itself. You will not be like, how did they know you want this thing or you need this thing or you searched about this thing? So they are using what? They are recommending ads for you based on your what? On your interaction. That's why when you go to site, you will see accept cookies. Those cookies are used to determine your interactions. They will use it to track your interactions. So that is why sometimes you can decide to not accept those cookies. They won't be able to track your interactions on that website. But in some websites, you will discover that if you disable that cookies, what you are able to do on that site will be limited. There are some websites like that. You won't be able to do much on the website. They will limit what you are able to do there because they believe in you accepting those cookies. That is what they will be. It's just as if, I'm not saying they are selling their data, but that is part of those things they will give to all these maybe Google AdSense, all this to use for ads for the advertising. They will also get paid, and that is how incomes are being generated by all these companies. So that's why we can't really blame them. But these are ways where machine learning has been applied. Speech recognition using deep learning for voice commands. You can, maybe you have Amazon, Alexa, Siri, even Google, Google Assistant. You can just call it, hey Google, Alexa, Siri. It will recognize your voice. Can you see what I'm just saying? Even right now, as I just said that, my phone had to pop up. My assistant had to pop up just now. That is to tell you speech recognition. Because immediately I said it, my phone, the assistant popped up. So these are ways where machine learning have been applied. It's to recognize your voice. This uses deep learning for voice command. Why even some that might not really recognize, anybody can see it and it will still recognize their voice. That is like wake up. It's recognizing speech. Someone is trying to call me. All this why it might not be, it might be asleep. But once we just mention that keyword, we call it wake up keyword, maybe when we are designing embedded system, tiny ML on embedded system. So once you just call that wake up word or so, it will wake up, it will answer and start listening to whatever you are saying. But once you didn't call that thing, anything you are saying is not listening to it. But so far you call that word, it answers and starts listening to everything you say after that word for some period of time, then before it exits. Also, reinforcement learning is used for self-driving cars. Yeah, this is just as because the cars, we said they are self-driving. How do they learn to drive better? The autopilot and all that, they use reinforcement learning for them. And they use deep learning on their camera data. So it's combining reinforcement learning and also what deep learning. So this is just what the session 2 about. We've been able to talk about the types of machine learning. We've been able to differentiate between AI, machine learning, and deep learning. So which I believe you now know the difference between them. And I make some scenarios how machine learning is different from the traditional programming. How is different from the traditional programming. So I gave those examples. So now some self-check questions. So what is the key difference between AI and machine learning? As we've said, AI broad goal is to what? To simulate human intelligence, to imitate human intelligence, human reasoning. What humans does, AI is trying to imitate it. So why machine learning is a specific approach that is used to achieve AI, achieve AI by having machines learn pattern. Yes, we want AI to be able to simulate how human behaves, but how can it do that? It needs to learn. So one of the methods that AI used to learn is what is machine learning. So it's a specific approach where AI learn patterns. So without being explicitly programmed. So another self-check question is, which machine learning type would you use to predict your next month electricity bill in kilowatts? The answer is there, but okay, let me just say in the supervised learning, that is the first thing. You need supervised learning. And which type of supervised learning? Regression. Because we say regression, you predict a what? A number. So your output is a what? Is a continuous numerical value. So that is why it's regression and not classification. So, So for this next one, he said Jumia wants to group its 2 million customers by the way they purchase, their purchasing behavior, and they don't have any predefined categories. So which ML type is this? We said if you don't know how you want to group something, unsupervised is the best for that. And you can imagine they want to group 2 million customers. So is it one person that will not be thinking, oh, this customer, this is the way you purchase good, it will check this customer. By the time you start taking each customer data up to 2 million customer, and you try to find patterns, find this, it will be too much. So the best machine learning to use for that is what? Is unsupervised. And the specific type of unsupervised learning is what? Clustering. You can just determine how many groups do you want the 2 million customer to be, maybe in 2 or 3 groups based on the way they purchase product. You know, categorize one, like maybe budget customers, those ones that are premium, those ones that buy things no matter the price, those ones that are just seasonal. Maybe when is only there is a wolf, there is Black Friday, stuff like that. So we can use it to what? To group. Yeah, unsupervised is the best for that. So another one is we have a game playing AI. We have a game playing AI learns to win by what? By playing millions of games and receiving +1 for a win, -1 for a loss. Which ML type is this? This is simple and direct reinforcement learning. When you even the term, when you see a game, anything that when you are building a model that involves game, reinforcement is the best. And it said it learns to win. It has to play millions of games. So it's learning to win by having to play millions of games. It's reinforcement learning, because it's reinforcement learning. Your game is like the agent. You put it in an environment, that is, you just place it in the game, and you might just give it the rules. Oh, when you do this, this is how you score, this is how you, I'm just giving an example. So it will not start playing millions of games to learn. And you can see the reward and penalty here. When it's having reward, you are giving it +1. When it's winning, when it's losing, you are giving it -1. So reinforcement learning is what is the best for that. So we'll be calling it a day here on section 2. So the next section will be moving into data collection, processing our data, and exploratory data analysis, which I believe we've done in our internship class, especially in level 2 of the internship, where we work on visualization. So we also see how those things are applicable here. So I don't know if you have any question or anything to say before we round up the section. Is there any question? Hello, can you still hear me?
Yes, sir.
So I said, is there any question from
I don't
what
have
has been?
No question.
Yeah, I'm with you.
Well explained.
Okay, all right. So what of Precious? Do you have question from your own end?
no, sir, I don't have question.
Okay, all right. So if there's no question, we'll calling it a day here. So we'll be moving to section 3 by next week also, by section 4 also. So by the time we are done with the section, we'll even during the section we'll start some little, maybe if we can do some little hands-on. But after this section 4, that is where we'll be having hands-on. The most of the sections will not be hands-on. But at least we need to still explain some things before we get to the hands-on. Yeah. So section 1, 2, 3, and 4, and we have the practical and the project. So, and as I mentioned in the last section, one of the projects we work on will be on the one of fraud. Is it no? Yeah, no default. If someone should apply based on the person's information, we know if this person should apply for a loan. Is he going to default or not? So if the person is going to default, we won't approve his or her loan. If the person is not going to default, we approve the loan. So we'll build a model that will do that, and maybe another one on classification, another one will be on regression. We'll try and touch at least maybe one project on supervised learning, classification, regression. We'll also try and touch one on the unsupervised learning, and we'll try and give a deep intro, deep learning intro into deep learning intro. We'll do an intro that will do a little CNN, neural networks. So we'll be calling it a day here. Thank you all for joining. So we'll see you next week.
Yes.
Have a good night.
Thank you so much.